Okay, welcome everybody. So in the previous videos, we talked about the position option in particular with bar plots and how we can use stack versus dodge versus fill. There is another position which could be useful to use, which is the jitter position, um, which it might be more useful to think about that in the context, for example, of like a scatter plot, and where that might be more natural to use. So I'm going to use a data set that comes from a package called hist data. So you might have installed and loaded that way back at the start of this module, and it's been a while. So I just included this code cell down here, so that you load and install this again, since again, you might not have this loaded in your active session right now. So I'm just going to run this code cell. This is going to install the hist data package, and then it's going to load the hist data package. And the only thing that we need from this package is a data frame called Galton. So that's what this command is going to load, that Galton data frame into our session. And there are two variables in that data frame. There's parent and there's child. They're both continuous numeric variables. There's 928 observations in them. So these are both giving the height um, of a child's mother and father in inches. And the child is giving the height of the child in inches. And these values are rounded off to the nearest 0.1 inch. So if we go ahead and create a scatter plot of that data, it looks like this. And again, there is a lot of over plotting in this graphic. So there's 928 data points in this data set, and we're not seeing all of it because like this one point actually is like there's like 100 points that are plotted right on top of each other because data was rounded off. So there's a lot of data points that correspond maybe to like the same value. So if we use the jitter position, um, it just introduces a little bit of noise and just shifts things slightly so that we can see more of the data points and shifts them around a little bit. And so this is what happens when we kind of introduce that jitter position over there. And this just allows us to see more of these data points. So this one point that we might have seen over here is actually like a cluster of like, 30 different parent-child combinations over here. So my main point here is just to illustrate that there is a jitter position that wasn't really all that useful to illustrate in the context of a bar plot, but might be useful if you're in some context like working with a scatter plot. And the very last thing I want to mention at the end of this module, kind of working with a coordinate system is kind of beyond the scope of what we're getting into, but there you can really fine tune these plots using coordinate systems. ggplot uses the Cartesian coordinate system. You can kind of embed other coordinate systems in here. Here I've created a box plot for to look at the distribution of body mass versus species. So I've plotted body mass on the y-axis and species on the x-axis. There's a command which is called coordinate flip. So over here I added a layer, coordinate flip. This just flips the x and the y aesthetics. So instead of getting these box plots that are aligned vertically, just flips them. So instead we get box plots that are aligned horizontally. And it's the same exact thing that we could have just done if we manually just flip the X and Y around. But I just wanted to kind of mention that property. That also comes in handy if you want to switch the role of the predictor and the response variable on a scatter plot and things like that. Okay, so that's a wrap for this module. That's a wrap for ggplot2. We'll move on to more data wrangling type of content next week and less visualization stuff next week. So we'll be working with the dplyr package and talk about how we can wrangle up data. But I hope you had some fun with ggplot2. And that's a wrap for module 6. Thanks, everybody.